Now multiplication and division of a vector by a scalar. So let us say that you are having a vector a. So if you multiply your vector a by a certain scalar, let us say lambda, then you will be getting a totally different vector. Let us say that vector as c. Now depending upon this lambda will be your vector c itself. So this lambda either can be less than 0, it can be equal to 0, it can be greater than 0 itself. Okay, means it can be of any magnitude. Okay, it can be of 0 and 1, in between 0 and 1 it can be of greater than that of 1 also. Okay, so we'll be taking every possibility over here. Okay, so let us say that it is less than that of 0, that is it is having a negative associated with it. So let us say that the value is -1. So what's this -1 representing? So you'll be getting a resultant vector c after multiplying a -1 with that of a vector, that you'll be getting a negative vector itself. So c vector will become negative of a vector, that is c vector will be having the same magnitude as that of a vector, but he will be having opposite direction. Let us take another example of lambda equal to -2. Now if you multiply a -2 to this a vector, you will be having something like this -2a vector, which says that you are having a vector which is having a magnitude 2 times that of the prior a vector over here, but now your direction is being reversed. Okay, so you are having a reversed direction but greater in magnitude, a new kind of vector which is c vector. Okay, now let us take lambda equal to 0. So you will be landing up with c vector equal to as a 0 vector over here. Let us take our lambda in between 0 and 1. So you will be having a vector c as, let us say that my lambda is 0.1. So c vector will be as 0.1 of a vector. So you will be saying that okay, my vector c is having a diminished magnitude, a smaller magnitude, but the same direction as that of a over here, because there is a positive sign. So my direction haven't been changed. Okay, now let us have a value of lambda very much greater than that of 0 itself, for example 10. So I can say that okay, my new vector is 10 times of that of my old vector, 10 fold of my old vector. So the magnitude is 10 times that of my old vector, but the direction is not being changed. Okay, so that's the multiplication of a vector by a scalar quantity. Now let us talk about the division of the vector. So what you can do is you can have the division as follow by a simple number m. Okay, so you'll be having a totally new vector. Now this m again can have a value less than 0, a value equal to 0, a value in between 0 and 1, and a value greater than that of 1 itself. Okay, so if you are having less than 0, then you can say that okay, I'm having a vector, I'm having a vector, let us say that m is -10. So I'm having a vector whose magnitude is diminished and the direction is also reversed. Okay, that will be my c vector itself. Refrain yourself from taking 0 m, because if you take m equal to 0, then you will be having an infinite answer which is not defined. Now let us take another example of having m as a value of in between 0 and -1 over here. Okay, so if you are having m as -0.2, then you will be landing up with -0.2 a vector, which says that -5 a vector. So here you can say that okay, my vector is now 5 folds of that of my old vector a vector, but the direction is being changed. Let us have the same procedure with 0 to 1. Let us have plus 0.2. So I can say that okay, my new vector is 5 folds of the old vector, because I am taking a value in between 0 and 1, but the direction is retained. Then you can have a value 1 greater than that of a value of m greater than that of 1 over here. So you can say that okay, my new vector will be coming out to be something diminished than that of the old vector, but the direction is retained. Okay, direction is retained because there is a positive sign over here. Now let us talk about the basic laws, the addition law and the subtraction law of vector over here. So first we'll be taking the triangle law of addition vector over here. So let us say that you are having two vectors, namely a vector and b vector, and you want to add them up. So how you can add them up? You have to follow certain steps. That first you have to keep vectors such that tail of one vector coincide with the head of another vector. So here I'm saying that this is my vector b whose tail, this is the tail, is coinciding with the head of the a vector over here as follow. Okay, so this is the head of the a vector over here. So my tail of b vector is coinciding with the head of the a vector. Now you have to join the tail of the first vector over here to that of head of the another vector over here. So tail of a will be joined to the head of b. Okay, then you have to mark the vector itself. So this will become a new vector. Let us say that it is c vector over here, which is the added up vector. Okay, so c vector can be represented as the sum of two vector, which is b vector and a vector itself. Okay, so that's the triangle law of addition of vector. Now here you can observe few things, that you are able to add only two vectors, namely a and b, that gives you a new vector c. And that's why I can say that it's a triangle law of vector. Why? Because there are only three sides associated with the triangle itself. Now in a real case scenario, you want to have more than that of one vector itself. So you are having here 1 2 3 4 vectors to be add up. Okay, you want to find the resultant add solution of these four vectors over here. So you can apply the polygon law of vector, who says that okay, you can have many sides, you can have as many as vector you want to add up. Okay, so that's why it's the polygon. You are not restricted by the number of sides. So what you have to do is, again you have to follow the same rule, that you have to join the tail of one vector to that of head of another vector. So here this is my a vector, so I'm joining the tail of b vector over here with that of a vector over here. Okay, then I will be landing up with a new resultant vector, let us say r1 vector. Now join the head of the b vector with that of tail of the c vector over here. Okay, fine with that. You will be landing up with a new vector, let us say r2 vector. We'll calculate them in a few minutes, but let us join them by using the triangle law itself. Now the d vector tail will be joined to the head of the c vector itself. So d vector join with the c vector, giving you another resultant vector, let us say r3 vector. And don't forget to mark the arrows also. Now let us talk about the r1 vector. As you can see, this is a triangle, okay, so I can say that r1 vector will become a vector plus b vector. Okay, now let me change my pen over here. So again, as you can see, this is the common point o. So this is again a triangle, as you can observe. So c vector ended up to r1 vector over here gives you r2. So c vector plus r1 vector gives you an r2 vector. In the similar fashion, r3 vector will be equal to r2 vector plus the d vector. So that's the polygon law of vector for you guys. It's very much easy, just a simple application of triangle law itself.